Hi students, just checking in from Carnegie Mellon, Qatar. Hope you had a great day. Today I'm going to do a little tutorial on what you were supposed to learn today. So I miss you guys. Okay, so today you guys learned about reproductive physiology and non-disjunction. And so I just wanted to go through, if you haven't done the homework yet or whichever class you're in, anyway, in one part you're going to do non-disjunction, in the other part you'll do reproductive physiology. So I just want to go through the main ideas that you should have gotten from these lessons. So first, the differences between male and female meiosis. So in males, spermatogenesis, and I'm really simplifying meiosis here because I've got other videos that go through all the details of meiosis. But the idea here is that meiosis 1 splits apart the homologs, and then meiosis 2 splits apart the sister chromatids. You end up with 4 spermatids or sperm that are all equal in size. The difference is that in oogenesis, in a female, when we make eggs, we focus on just one egg because it has to carry all the cytoplasm and all the organelles that it needs to grow the baby until the baby can implant and grow its own placenta. So we can't afford to split evenly. So that's the main difference, right? So in the first split, we do split the genetic material evenly, but all the rest of the cellular material just goes to one egg and the other one remains a polar body. And this particular polar body right here is going to stay in the ovary. It's not even going to ovulate. This is what ovulates each month. And then it will just slough at the end of the month during your period unless it gets fertilized by a sperm. If it gets fertilized by a sperm, it will split one more time, spit out another polar body with the genetic material, and then hopefully the sperm stays with this half and not this half. If it goes with this half, you'll actually miscarry, which is not uncommon. About 2 out of 3 fertilized eggs will miscarry. But if the sperm stays here, then it will grow into a baby. All right, so that's the difference between spermatogenesis and oogenesis. So now let's talk about non-disjunction. So looking at spermatogenesis, if non-disjunction happens in meiosis 1, that means your homologs failed to separate, right? Whereas if it happens in meiosis 2, it means that your sister chromatids failed to separate. So going back, if it's meiosis 1, you could potentially have different alleles on the duplicates. If it's in meiosis 2, then the alleles should be the same on this one, but on here, on here, your alleles will be identical because it comes from identical chromatids. And so that brings us to one last thing. So if let's say that you are a carrier of a genetic disease and so is your mate. So let's say you're a woman, you're carrying a genetic disease, your husband's carrying the genetic disease, your chances of having a baby with the genetic disease, if it's recessive, is 1 out of 4. And so you don't actually have to take that risk. What you can do is in vitro fertilization. So what they do is they have you, you ovulate, right? So this is what you're ovulating. This polar body stays in the ovary. And then once you ovulate, they actually harvest this egg right here and they let it go through the second division in a test tube, because this polar body gets spit out. And then we can actually destroy it and analyze the DNA inside. You can't do that with a sperm, right? Because the sperm, if you destroy it and analyze the DNA inside, the sperm is dead. But this, right here, you can look at this polar body. So in this case, if we look at this polar body, since these two should be sister chromatids, what do we know about this polar body? Well, it's carrying the little a. And so if you pull out the polar body and see the little a, then you're likely to not use that particular fertilized egg because it has a little a too, and you can't guarantee that the baby's going to be okay. So that's generally how they do that. The one caveat is, what if crossing over happened right here? Okay, so what if the 2 chromatids cross over? You see how I did that? So now there's a big A and a little a, and a big A and a little a. So now in this case, this particular chromatid, I didn't do it here, but it's half blue and it has a big A. So there's a possibility you pull out the polar body and see that it has a big A, even though the baby actually has the little a. And so what they actually do is let the embryo grow into like a 16 cell stage, and then they'll pull out a cell and confirm, because that won't hurt the baby, and confirm that you didn't get 2 little A's. Anyway, so that's what you should need for doing both parts of this assignment. Hopefully that made sense. Thank you.